Question 22. So when we have to cube all of these terms inside a bracket being multiplied together, I think the best thing to do is to start off just by attaching the cubing to each of the bits. So 3 cubed, x squared all cubed, and y to the power of 4 all cubed. So bit by bit, 3 cubed is obviously 3 times 3 times 3, which is 27. When we get a situation like this where we've got something within a bracket with a power and a power outside the bracket, we multiply these two together, so that's x to the power of 6. Reason being, x squared all cubed is x squared times x squared times x squared, which is x to the power of 6, and similarly y to the power of 4 all to the power of 3 is y to the power of 12. Now in part B, when we get one like this, we need to choose to factorize the numerator and factorize the denominator and pray that a couple of those factors cancel out. So x squared minus 9 is a difference between two squares. That's an x plus 3, x minus 3. When we go and factorize the denominator, some of you will be able to do this by inspection. I've got this sort of fairly long-winded method here, but either way you should get 2x minus 1 in a bracket, x plus 3 in a bracket. The x plus 3's cancel out, leaving us with x minus 3 over 2x minus 1, and at that point the brackets are no longer required, so that's the final answer. Quickly on this factorization, if you're not familiar with this method where we've got a coefficient of x squared, we're looking for two magic numbers that multiply make minus 6, but add to make 5, which is 6 and minus 1. We split the middle term either way. It could either be 6 minus 1 or minus 1, 6, but this 5x becomes a 6x and a minus x. Fully factorize the first two terms, fully factorize the third and fourth term, giving us this. You will note that we have a repeat of the bracket, so our pair of brackets is what's not in a bracket, the 2x minus 1, and the repeated bracket, the x plus 3.